Okay, here we have a GE 810 chassis. This is a late 40s black and white television chassis. Got it set sideways here, a little test CRT installed at the bottom of it here. Haven't done anything with it yet. I just decided I'd go ahead and have a little bit of fun this afternoon and check this thing out. Now, what I'm going to do is I pulled the horizontal output tube out because I'm going to be slowly applying power to this thing, and I don't want this thing, and I don't think it's good for horizontal outputs to have less than full power in case the oscillator doesn't run or something like that. But I've got a couple that this has a low two B plus supplies. One's a 5U4 and the other's a 5B4. You see it right here. V21, 5Y3, pin 2 should have 310 volts, and the V16, the 5U4, should have 380 volts. So I've got those two tubes hooked up. I got a digital meter here and an analog meter here. I've got my variac, which is a meter variac. I've got amps here, volts here. And the idea is to slowly apply power and just see what happens. This set hasn't been retouched. It looks fairly unmolested, i.e. there doesn't seem to be a lot of cap replacements. I see mostly old wax caps. So my guess is it hasn't had a lot of work done on it. Let me just talk about that for a minute before we actually get into the test. I know most people say, oh, wax caps got to be replaced. Yes, I agree. They will all be replaced. But frequently you will find that a lot of these capacitors, even if they are somewhat leaky, which is a typical failure mode, the circuit will still tolerate and use them. Tube circuits are surprisingly tolerant of that. The only exception to that would be perhaps the grid circuits where you don't want any leakage, and no doubt there'll be a problem. My point is to kind of baseline it and see what it does before I touch it, rather than just shotgun recapping. I'm not saying there's anything wrong with that. You know, if that makes you feel happy, I can certainly understand the rationale behind it. I'm not saying it's wrong, but I do like to try to get a baseline, see what it does, and then if it works at all, you can replace a few caps, and you can see what happens if it improves, things get better. It's just kind of a way to not make any major mistakes. When you have capacitors like this that are all over the place, if you screw up and replace a capacitor and connect it back incorrectly, which does happen, it happens to the best of us, or you put the wrong value, you can introduce a fault into a TV that can be pretty hard to diagnose. It's not impossible, but it's not fun either. I've already looked at a few of these caps. Like I know some of this circuit here, there's definitely grid caps, and you know, I'm sure there'll be a problem. But again, let's just go ahead and see what happens. First things first, I did check the power supply, the transformer. The primary had about 2 ohms, which is correct according to the schematics. So I'm not too worried about a power transformer being shorted. And the continuity was working, so the on-off switch down in there was working fine. So I'm going to go ahead and start up the variac. Nothing happening there. Nothing happening there. Of course, this uses tubes, so I'm not surprised. That low voltage, the tubes probably aren't conducting very much. So I'm going to ramp up. This is a little stick here. There's a homegrown. Oh, I can already see voltage starting to come up. That's the 1,000 volt range, so I'm almost at 100 volts already here. I'm at about 21 volts there. Let's go ahead and ramp this up to, say, about 60 volts. Okay, that's 200 volts, and I believe I said this has to go to 380 at full power, so that's not looking too bad. 200 volts at about 60 volts, and the amp meter is barely moving at all. So I don't think there's any shorts anywhere. I also did check these two circuits for resistance before turning it on, and in both cases they were fairly high, which is what you want. You want something at least 10,000 ohms on the B pluses to make sure there's no shorts in the B plus. And what this does now is gives the electrolytic capacitors a chance to kind of have a soft start, which is the main reason behind this variacing. For those of you who don't know, one of the reasons why you variac is to have a soft startup. Look for smoke, look for bad things go wrong, and give these old vintage capacitors, electrolytic capacitors, a chance to recover. Now, I'm not saying that they should not be replaced, just like the wax. You can see that one, that capacitor's gotten bubbly. Anyway, I'm not saying that it shouldn't be replaced. I'm just saying that sometimes they're okay, sometimes they not replacing them, there's introduced a certain amount of risk that the set could have a problem later on. But again, it's all about getting a baseline, trying to find out what works, where are we, what's going on. This is still coming up. I'm at the 68, 69. This one's coming up slowly. I think it might be selling down at about 68, 69. That's at about 200. And that gives me a little cause for concern, because if you see here, this pin 8 is 380, and this pin 8 is 310, so they aren't that far apart. Yet here, I'm at 67 versus 200, which makes me think that maybe this the 5Y3 tube has got too high a load on it. It might be a bad capacitor in there sucking down the current, or could be any other reasons, but we'll see. I'm just going to let it sit here for a while and see if anything changes. I don't want to go up too fast. Look for smoke, look for anything going wrong, and come back to this and continue later. But this is the 5Y3. This is the GE 810. Oh, I also have this little guy here, which is handy for doing high voltage tests. When I pop the horizontal output tube back in, I'll hold this up to the flyback and look for glowing if there's no raster coming off this test CRT. So more later. We'll see how this goes. I'll keep an eye on this. Oh, it's up to 72. So it is coming up. It's still coming up slowly. We'll see where it ends. That could be the capacitor reforming. This is one reason why you do exactly this. There's no reason to slam it with 400 volts, which if the capacitor has not been used in years and years and years, you can almost guarantee a failure. This one's still sitting here at about 200. The other thing you can do is you can literally feel the capacitors, feel for heat. They're stone cold, which doesn't really mean anything at this point. This is this cap here is a low voltage cap that actually gets its voltage from a selenium rectifier. So I'll have to kind of keep an eye on that. I don't want that selenium rectifier to let go, which make a real bad stink. Anyway, more later.